Hey class, this is Mr. Roberts, and we're going to be looking at the homework for section 2.2.3. It runs questions 75 or 71 through 75. So let's start with 71. Sometimes the quickest and easiest 2 points to use to graph a line that is not in slope-intercept form are the x and the y-intercepts. Determine the x and y-intercepts for the two lines below and then use them to graph each line. Write the coordinates of x and y intercepts on your graph. So if we look at these, one of the things I actually talked about this in class today, interestingly enough. If I want to know where a function is crossing the y-axis, right? When I'm crossing the y-axis, that's the moment when x is equal to nothing, right? If you think about it, x's are positive on this side, x's are negative on this side, and the moment that I'm crossing the y-axis, x is equal to 0. So if I want to find my y-intercept, I'm just going to set x equal to 0 and then solve my equation. And kind of similar things happen if I want to find the x-intercept. You'll notice for this point, right above it, the y values are positive. Below it, the y values are negative. But right on that point, y is equal to 0. So if I want to find my x-intercept, I'm going to let y equal 0. So it's kind of a powerful way to pick up a couple points if an equation is not written in slope-intercept form. Both of these equations are written in standard form. They have all integer coefficients, right? This is a positive 1, if you will, minus positive 1x minus 2y equals 4. This has also integers, right? A 3, 6, and a 24. I can transform these equations into slope-intercept form if I wanted to and use those, but I'm just going to go ahead and figure out the intercepts. So first thing I'm going to do to find my y-intercept, right, if I want that, I'm going to let x be 0. So if I let x be 0, right, this value is going to become 0, and this equation becomes negative 2y is 4. Therefore y, if I divide both sides by negative 2, y is negative 2. So I've got this point at 0, negative 2. 0, negative 2. 0, negative 2 is my y-intercept. And I can do something similar if I want to find the x-intercept, right? To find the x-intercept, I'm going to let y be 0. So this is going to become 0. And when I do that, this term, right, this becomes minus 0. So the equation simply becomes x is 4. So that's my x-intercept. It occurs at the point 4 comma 0. So here it is, x is 4, y is 0. And now that I've got those 2 points, right, it's just a matter of grabbing my straight edge, lining it up, and once I'm satisfied that I'm hitting through, the center of those 2 points, just draw the line that roughly goes through those. And I could put arrows in each direction indicating that the domain, it continues in both directions, right? So let's try the same thing with the other equation. So again, when I want to find the, I guess we'll do y first. Let me try and make this more organized. If I want to find the y-intercept, right, x is going to equal 0. And then when I want to find the x-intercept, I'm going to let y equal 0. So first we're going to let x be 0, so this term goes away, and the equation becomes 6 times y is 24. If I divide both sides by 6, I believe I get 4. So y is 4. So my y-intercept happens at the point 0 comma 4. And let's do the same thing for the x-intercept. For the x-intercept, we're going to let y be 0. So this term is going to become 0. That means the equation becomes 3x is 24. And if I divide both sides by 3, I get that x is 8. So the point 8 comma 0 is my x-intercept. So it's pretty easy to plot both of those, right? 0, 4 is my y-intercept. There it is. And the other point that I have is 8, 0. 8, 0 is my x-intercept. And then with those 2 points, we're just going to grab the ruler tool again, line it up. And as soon as we're lined up perfectly there, we're just going to just drag that across. And it's very nice to put arrows indicating that it continues this direction and it continues this direction. So those are, I think it's a pretty handy way to deal with equations written in standard form, right? To just go ahead and find the x-intercepts and the y-intercept. Let's move on to the next question. Next question says solve each of the following equations. So this first equation, if I want to solve for x, I'm going to choose to subtract 2x from each side. Again, if I have equal things and I take away equal things, it has to be the case that these things, 8 is the same as x minus 4. And then I'm going to add 4 to both sides, so this becomes 12 is equivalent to x. So my solution is x is 4. Now, I want to verify that, and it's not hard to do, right? So I think x is 4. 2 times 4 is 8, so this side becomes 8 plus 8, which is 16. On the other side, I've got, I think I've made a mistake. I think I've made a mistake. Interesting. I made a mistake. 2 times 4 is 8. 8 plus 8 is 16. Oh, of course I've made a mistake. I can't believe I'm sitting here looking this hard at it. Hello? X is 12, right? What? Oh my gosh, you're probably watching this like, hey, crazy old guy. There's a problem with what you've written there. X is 12. Yeah, I don't know how I made it 4 when I flipped that. So now that I correctly see that X is 12, right, I've got 2 times 12, which is 24, and to that I'm going to add 8, and 8 plus 24 I believe is 32. On the other side, I've got 3 times 12, right, 3 times 12, which is 36, and I'm going to take away 4 from that, and 36 minus 4 is 32. So when I put this value in, right, a value for x is a solution if it makes the equation true. And you can see when I put 12 into both sides, I put 12 into this x and 12 in for x here, it does really make both sides 32 or equal to each other. Embarrassing. Let's move on to part B. Part B, we're going to solve the equation. Let's see, I'm just going to take away 3 from both sides. So I've got 1.5w equals 2 times w. And you could be saying, hey, Mr. Roberts, there's no way that's possible, but there is a way. I'm going to take away 1.5w from both sides. When I do that, this side becomes 0. It's very important I write that down. 1.5w minus 1.5w is 0. And on the other side, I've got 2w minus 1.50, so I'm just going to put 1/2 w. And maybe you see this now, you don't need to go further, but if I want to get w alone, I'm going to multiply both sides by 2. Well, it turns out when you take 2 and multiply it by 0, you get 0, and on the other side, 1/2 times 2 is 1, so this is just w. Well, guess what that means? It means that w is equal to 0. And sure enough, if I put 0 in here and 0 in here, it does say that 3 is equal to 3. So truly, w equals 0 is a solution. Final, oh no, there's 2 more. We're not even close. Let's see, on this one, let's collect up some like terms. So I've got 48, and I want to add to that 23. If I add 48 and 23, I think it's 71. So I'm going to write down 71 plus 8x is 7. So now I'm going to take the number 7 and I'm going to subtract from that 71. When I do that, I believe I get negative 64. So 8x is negative 64. And if I take negative 64 and divide that by 8, I believe it leaves me with x is negative 8. So I think x is negative 8 is my solution. Let's try that. 8 times negative 8 is negative 64. So I'm going to add 24, negative 64, and 23. And when I do that, I'm doing this on a calculator. And I have 48, and I'm going to add plus negative 64. And I'm going to add 23, and when I do it, yeah, I get 7. So when x is negative 8, it makes both sides of this equation equal to 7, right? 7 is 7, so it does check. And finally, let's move on to part D. D has the equation. Yeah, here we are. Let's go ahead and combine these, right? When I combine those, I can see on here I have 6 times x and then plus 17. On the other side, I have 6 times x minus 21. Both sides have this term 6 times x. So I'm going to subtract that from both sides. And when I do that, I get this 21 is 17, which is a contradiction. And the moment we see a contradiction like this, right, we know that there is no solution. It doesn't matter what value of x I pick. I'm never going to get 21 to be the same thing as 17. So no solution there. Let's move on to question 73. 73 says a consumer magazine collected the following data for the fuel efficiency of cars, miles per gallon. So you can see, oh, compared to the weight of the car. So we've got the miles per gallon on the y-axis and the weight of the car in thousands of pounds. So don't think this is 2 pounds, right? That's 2,000 pounds because these numbers are in thousands of pounds. And when I look at this relationship, it looks like there is some association. It seems to be that the heavier a car is, the lower its fuel efficiency is, the lower its miles per gallon number is. So we've got this equation that says E equals 48 minus 8.4 W. The weight of the car, W is the weight of the car in thousands of pounds, and E is the fuel efficiency measured in miles per gallon. So the first question we have is, what does the negative 8.4 in the equation represent? What are the units of this number? Well, this number is the units of that number would be miles per gallon per pound, P-O-U-N-D. And how I got that, the unit, is I'm looking at, I know that's the slope, it's the rate of decrease for this. So that slope pattern, right, the change in y divided by the change in x. Well, the units of y are miles per gallon and the units of x are pounds. So the units of that rate are miles per gallon per pound. So I would say it's the decrease in efficiency, E-N-C-Y, the decrease in efficiency per pound weight increase. Well, actually per 1,000 pounds, per 1,000 lb, per 1,000 pound weight increase. So as the weight increases, the fuel efficiency is decreasing. What does the 49 in the equation represent? What are its units? 49. Oh, 49. Oh, there it is. Oh, that is the fuel efficiency. That's crazy. So for that model that they built, 49 is the fuel efficiency for a car with weight of 0, right? So it says what does 49 represent? What are its units? So that 49, right? It's the y-intercept. So that's 49. It's what does the 40? Okay, it's the miles per gallon for a car that weighs 0 pounds. So impossible, right? We don't have a car that weighs 0 pounds. But for this model, if you were to extend it out and get a car that weighs 0 pounds, that would be it. So it is the y-intercept for the problem, and the units for it is well, it's right here, right? It's miles per gallon. The units of that are miles per gallon. So So the next one, it says describe the association between fuel efficiency and weight. I would say as weight, WEIGHT, increases, miles per gallon or fuel efficiency decreases, DCREASES. Look at me writing instead of the word increases. That's so bad and not so bad. Finally, Cheetah Motors has come up with a super lightweight sports utility vehicle SUV that weighs only 2,800 pounds. 2,800 pounds, right? What does the model predict the fuel efficiency would be? Apparently, on my paper answer key, I've got this wrong. Thank you to the two students who told me I had an error there. I appreciate that. And I'm recording this now with the correct solution as a result. So this says efficiency, right, in miles per gallon is the 49 miles per gallon minus 8.4 miles per gallon per pound times a number of pounds. So I'm going to multiply by a number of pounds, and the pounds is 2,800. Dude, this is amazing if you think about it, right? Efficiency is 49 miles per gallon, right, minus 84, and then this is miles per gallon per pound, lbs. That's the big denominator there, and I'm multiplying this by 2,800 pounds. And when I do that, what's beautiful, it's just amazing, is the fact that the units of this numerator and this one cancel, and my answer becomes all just miles per gallon. Except this was 8.4, wasn't it? Yeah, it's 8.4, not 84. So don't forget a decimal there. So if I do the calculations here, I'm going to take 49 and I'm going to add to that 8.4. Oops. 8.4 times 2,800. That is impossible, right? I'm clearly using that. Well, really? That can't be right. So it says, what does the model predict the fuel efficiency should be? Well, the answer I just got was wrong. Okay. Yeah, that's right. It's the weight in pounds. Yeah, I can't put 2,000. I can't put the number 2,000. If the weight is 2,800, right? The weight in thousands of pounds should be 2.8, right? Because remember, it's set up above that W was the weight. What did it say? It says W is the weight in thousands of pounds. So if I've got 2,800 pounds, that's 2.8 is what's supposed to go here. This is never going to work. Well, I got a number, but the number was completely unreasonable. So let me try that again. So now I'm taking the number 49, and I'm just going to subtract from that 8.4 times 2.8. So 49 times 8.4 times 2.8, and I get that the projected fuel efficiency should be 25.48 miles per gallon, which is, I mean, it's okay for an SUV. I mean, a Ford Focus gets a lot better miles per gallon than that. So does a Honda. So yeah, there's that. But okay, so maybe it's a whatever. That seems like kind of a light car too to be. Oh, it says it's lightweight. It's a lightweight. It's 2,800. All right, so about 25.48. Let's move on. Question 74. Each part below represents a different situation. For each situation, determine the pattern of growth and the tiles in figure 0 or the y-intercept. Okay, so yikes. It looks like as I move forward here, I'm always adding one tile this direction, right? There were 3, and I added one more tile this way. And I'm also adding 2 above and 2 below, right? So 2 above and 2 below. So it looks like each time I'm adding 5 tiles as I move forward. And I could try and draw them, but I'm going to do this. I'm going to say here's X, here's Y. I know I've got figure 2, figure 3, and figure 4. Figure 2's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I think figure 2 has 13 tiles. This one should have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. It does 18. And if I add 5 to that, it would be 23. So I'm increasing by 5 each time. If I want to go backwards, right, when X increases by 1, Y increased by 5, I can figure out figure 1, and I can also find out figure 0. So if I subtract 5 from 13, I should get the number 8. So, I can imagine what that one would look like. And then if I subtract 5 again, I get the 0th term, and 8 minus 5 more would be just 3. So for this one, it says find out the growth. So I'm just going to write these down. Growth, G-R-O-W. Growth is plus 5. And then I'm also going to write down my y-intercept. No. It says figure 0. Figure 0 it has 3 tiles in it. All right, let's move on. Here we go. B, not a situation, but a graph. On this one, I can see that as X increases, this is a nice point here, and this is a nice point. So I can see that Y decreases by 2. It went down by 2 when X increased by 1, right? So my change in Y is negative 2, and my change in the X is positive 1. So my slope ratio, right, is that change in Y over change in X. So my slope ratio is just negative 2. So I would say it is, the growth is negative, right? Growth is negative 2, or its slope is negative 2. And the 0th term, right, or the 0th term, or the y-intercept, right, this case it's the y-intercept, is the number 3. That's fabulous. That's what they wanted. All right, there's two more here. Oh my gosh, are there 3 more here? Okay, the next one is C. C, super nice, right? This one has a growth of 3, up 3 over 1, if you will, or just 3. And the y-intercept, or the 0th term, is at negative 14. Fabulous. Let's look at D. Let's see, X is increasing by 1, X went up by 1, X went up by 1. So it's pretty safe for me to look at these. If I go from here to here, right, negative 2 minus 3, negative 2 minus 3 is negative 5. So it looks like this went down by 5. Negative 2 minus 5 is negative 7, correct. Negative 7 minus 5 is negative 12. So for D, my growth is negative 5. I'm decreasing by 5. And my y-intercept, oh, that's beautiful. Look they tell me right there when X is 0, my y-intercept is at 3. So y-intercept is at 3. And then finally, there's a question here. It says, which situation above is increasing at the fastest rate? Well, let's see. D is decreasing, so that's not growing. It is changing by going down by 5. C is growing by 3. D has a growth of negative 2. And this top one has a growth of 5, right? This one's growing by 5 each time. So the one that has the greatest growth is A, the tile pattern has the fastest growth. I don't know why, it's like I'm shouting at this point. It has the biggest growth, right? What is it? It's plus 5. It's growing by 5 each time. All right, I think we're down to our last question. Paula found a partially completed table that her friend Donna was using to determine how fast water evaporated from a bucket during the summer. That is fun. That is a good time. If you're ever sitting around in the backyard, geez, what are we going to do? I don't know. Let's just watch the water evaporate. You could just get they're doing it in centimeters, right, on the side of the bucket. And I guess you could do that. Just look at how far it goes down in centimeters. Maybe just stick a ruler in there and watch it. Oh, and days? Well, that's going to be a long time sitting around and waiting. But okay, let's see here. Every other day, she measured the height of the water remaining in the bucket in centimeters. Okay. And then it says, review the math notes box in lesson 1.1.2. Is this a proportional situation? Ooh. Well, let's see. Probably not the way this is set up, because man, if I was measuring how much the water decreased in centimeters, I could say it was, right? But if it's proportional, I have to be able to say that at day 0, I could say at day 0 there was 0 decrease, right? Day 0 it was 0 decrease. But really, with this data the way it's written, at day 0 I'm at 30 centimeters. So I'd have to say no, because it's not going through the origin. It's not proportional. That's what I'm saying. If it is proportional, is it increasing or decreasing? If it's not proportional, explain why not. I would say it's not proportional because it's not going through the origin. Not going through the point 0, 0. But man, I could tweak this where I say this is, if y is not the height, y is the decrease in height, right? If I was to change this, y is the decrease in height. All of a sudden, in centimeters, all of a sudden now, this would be 0, right? On day 0, the water didn't decrease at all. And the next day, it would have decreased by what? By 3? I'm just looking at this here. And then it would decrease. So it's like I'm stating that. Anyways, this is not the problem. This is the problem I got, right? So it's not proportional because it doesn't go through the origin. Now, every 2 days, right, it's decreasing by 3 centimeters, right? When the number of days goes up by 2, the centimeters in water goes down by a minus 3 from it. 30 minus 3 is 27. 27 minus 3 is 24. 24 minus 3 is 21. 21 minus 3 is 18. 18, 19, 20, 21. Yeah, I counted up. So that is completing the table. For this table, what is the rate of change? Include the units. Oh, the rate of change for this is, oh, I completed the table. It's up above. The rate of change is, I'm going to say it's minus 3 centimeters of water height per 2 days, right? That's the rate. It goes down by 3 centimeters for every 2 days that goes by. Oh, and then what is the unit rate? Yeah, the unit rate is like, when you take the number 3 and you divide that by the number 2, you get like 1.5, right? So the unit rate is 1.5 centimeters per 1 day, centimeters per day. So it's going down 1.5 centimeters per day. Negative, going down 1.5 centimeters per day. And so that's the unit rate, right? This is unit rate. So in a unit rate, the denominator is 1, if you will, right? So negative 1.5 centimeters per 1 day. And then finally, write an equation to represent the height of the water after any number of days. So they used x and y, so I'm going to say y is the height of the water, and it's going to equal minus 3 x plus 30, right? So when x is 0 days, that gives me 30. When x is 1 day, it gives me 27. When x is 2 days, it's 30 minus 2 threes puts me at 24. So that is the equation, gives me the height of the water when x is the number of days. And that is it. That's the last question. All right, class. Have a good evening. I'll see you soon.